We're going to be talking about integer exponents today, and we're going to start by defining what a zero exponent is. Any non-zero number raised to the zero power is equal to 1. As long as x is not equal to 0, then x to the 0 power equals 1. So anything raised to the 0 power equals 1. And we're also going to talk about negative exponents. If x is not equal to 0 and n is an integer, then x to the negative n power is equal to 1 over x to the n, and 1 over x to the negative n is equal to x to the positive n. So let's see that in action. Let's take a look at this first problem, 3 to the negative 2. Well, if we follow our rule here, x to the negative n equals 1 over x to the positive n, then we're going to be following that rule 3. Let me see if I can get my pen to work here. 3 to the negative 2 is equal to 1 over 3 to the positive 2, which simplifies to 1 over 9. Okay, we're going to erase this other mark here. So now let's go and do the next one. 2 to the negative 4, because the exponent's negative, it gives you 1 over 2 to the positive 4, which gives you 1 over 16. Now my pen is working, so we'll erase that mark I'd made in the previous problem. Okay, so now let's go to the next one. 1 over 5 to the negative 2. If your negative exponent's on the bottom, you move it up to the numerator, and that is equal to 5 to the positive 2. Because remember, if we have 1 over x to the negative n, it's equal to x to the positive n. So if the negative exponent is in the denominator, we're going to move it to the numerator. We don't need anything in the denominator. You can imagine it just being 1. So 5 to the second gives you 25. Okay, so let's go on to the next problem. 1 cup is equal to 2 to the negative 4 gallons. Simplify this expression. Well, if you have a negative exponent, something raised to the negative power, we write 1 over that number to the positive version of the power. So 1 over 2 to the 4th becomes 1 over 16. So that turns into 1/16 of a gallon. So let's go on to the next page and see if we can get some more practice with this. If you have a negative exponent, we have 4 to the negative 3. We write that as 1 over 4 to the positive third power. And 4 to the third power gives us 64, so we have 1 over 64. Basically, the thing to keep in mind is that you never leave a negative exponent in an answer. Let's write that down. Never leave a negative exponent in an answer. If you want to simplify it, all of the exponents have to be positive. All the negative exponents have to be taken out. This next one, 7 to the 0 power, anything raised to the 0 power equals 1. So that's all we have to do there. Next one, negative 5 in parentheses raised to the negative 4 power. That's the same as having 1 over negative 5 in parentheses raised to the positive 4. And remember, this means 1 over negative 5 times negative 5 times negative 5 times negative 5. And all of that gives you 1 over 625. The next one, we have the negative, but it's not in parentheses, and then 5 raised to the negative 4 power. This is like just keeping the negative in front of the in front of the problem and writing it as 1 over 5 to the negative 4. Or I'm sorry, positive 4 now. Let's erase that. And so that turns into keeping that negative and just bringing it along for the ride. We have 1 over 625. Next, we have 10 to the negative 4. That's the same as having 1 over 10 to the positive 4. And 10 to the 4th power, 10 times 10 times 10 times 10, gives you 1 over 10,000. Next problem. Similar to one we just did a few problems back, we have a negative number in parentheses raised to the negative 5 power, so we write that as 1 over negative 2 to the positive 5. And we end up with 1 over negative 2 times negative 2 times negative 2, writing it out 5 times. And if we do that out, we get 1 over negative 32. And you can actually write that as negative 1 over 32 with the negative out front. It's just, both of them are the same thing. The very last problem on this page, we have the negative 2 raised to the negative 5 power, except really the negative isn't being raised. It's just in front of the number, so we're going to put the negative down, and it's really 2 that's being raised to the negative 5. So we have negative 1 over 2 to the 5th, which gives us negative 1 over 32. That's because the negative wasn't in parentheses, that we did not actually raise the negative to a power as well. Okay, so you noticed all of these problems, and all of them, we got rid of the negative exponent and we simplified. So now, moving on. Evaluate each expression for the given values of the variables. We want to evaluate x to the negative 2 where x is equal to 4. So we're just going to plug that in place, 4 in place of x. So we're going to have 4 to the negative 2 power. So that's the same as having 1 over 4 to the second, which gives us 1 over 16. Next problem. We have negative 2, a to the 0, b to the negative 4, which we want to evaluate for a is equal to 5 and b equals negative 3. So we have negative 2 times 5 to the 0 power times negative 3 to the negative 4. Okay? Now, the negative 2 is not an exponent, so we're just going to leave that right where it is. 5 to the 0 is equal to 1. Anything raised to the 0 power equals 1. Negative 3 to the negative 4, that needs to move to the denominator. So it becomes negative 3 to the positive 4 once it moves. So we end up with, in simplifying it, negative 2 over negative 3 to the 4th power, which is negative 3 times negative 3 times negative 3 times negative 3, gives us positive 81. So we have negative 2 over 81. And the last one on this page, we have 8 to the negative 2 times b to the 0, which we want to evaluate for a equals negative 2 and b equals 6. We have 8 times negative 2 to the negative 2 power times 6 to the 0. So trying to simplify this, we have 8 in the denominator. We're going to move down the negative 2, which now is raised to the positive 2 power. And then we still have 6 to the 0, which is going to stay in the numerator, but that becomes 1. Anything raised to the 0 power is 1. So we have 8 over, well, negative 2 times negative 2 is positive 4, and 8 over 4 gives us 2. Moving on to our last page of problems, just kind of problems that sum up everything we've done so far. We want to simplify negative 5 over k to the negative 2. The negative in the 5 does not apply to an exponent, so it's going to stay right where it is. The k to the negative 2, the negative exponent's in the denominator. We're going to make it positive by moving it to the numerator. So we're going to have k to the positive 2. Next problem, 2r to the 0, m to the negative 3. Got to get rid of the negative exponents. The 2 is fine. r to the 0 equals 1, so we're going to have 2 times 1. M to the negative 3 has a negative exponent, so we need to draw a fraction bar and move it to the denominator where it becomes m to the positive 3, and we get 2 over m to the third. Moving on to the next one. A to the 0 is equal to 1. B to the negative 2. The exponent's negative, so it's in the numerator. We need to move it to the denominator, so it becomes b to the positive 2. In the denominator, we have c to the negative 3. It's got a negative exponent, so it needs to move upwards to the numerator, so we have c to the positive 3. D to the 6 has a positive exponent, so it's going to stay right where it is. So we have 1c to the third over b to the second, d to the sixth. Now we have r to the negative 3 over 7. The r to the negative 3 has a negative exponent, so it's going to move down to the denominator. The 7 is fine. It can stay right where it is. So we've got 7r to the third in the denominator. We don't have anything on top, so we're going to have to put a 1 there. And our last problem, we have g to the fourth over h to the negative 6. H to the negative 6 has a negative exponent, so it needs to move upwards to the numerator. The g to the fourth is fine, so it's going to stay right where it is, and we have g to the fourth, h to the positive 6 now. So that's it for integer exponents for today, and thank you for joining me.